students, welcome to physics class. Today we are going to discuss an important concept, that is relation between angular momentum comma moment of inertia and angular velocity. Once again, relation between angular momentum, moment of inertia and angular velocity. This is today our concept. First, go for discussion. What is angular momentum? L. Now, what is momentum of inertia? I. Now, what is angular velocity? Omega. Omega. So now our aim is to bring out the relation between angular momentum, momentum of inertia and angular velocity. And what is another formula for omega? Tau into theta. Sorry, omega is equal to T into. That means now today our aim is to bring relation between L, I, omega. Now go for discussion. Take x-axis, y-axis and z-axis. Take a particle at a point O. Take a mass of a particle m1 with position vector r1. Its velocity is tangent to it, v1. Now take another mass of a particle m2. Its velocity is perpendicular to it, that is v2. Position vector is r2. Take another particle mn. Its position vector is rn. Now draw a perpendicular to it. Its velocity is vn. Now take this whole is a system. Consider the system which is revolving anti-clockwise direction about an axis, about z-axis, that is with a angular velocity omega. It is moving in anti-clockwise direction. Now consider a rigid body rotating about a fixed axis with uniform angular velocity omega, full stop. Angular acceleration will be same for all the particles, since angular acceleration will be same for all particles. That is, alpha is same for all particles. At the same time, omega also same for all particles. Now, the linear acceleration will depend on their distances R1, comma, R2 and so on, Rn from axis of rotation. Next, the linear velocity will depend on their distances R1, comma, R2 and so on, Rn from axis of rotation. Now the linear velocity of first particle V1 is equal to R1 omega. Consider equation number 1. Now the linear momentum of first particle is P1 is equal to M1 V1. Equation number 2. Now equation 1 substitute in 2. Therefore P1 is equal to M1 into what is V1? R1 omega. Consider equation number 3. Now the angular momentum of first particle is L1 is equal to P1 R1. Consider equation number 4. Now equation 3 substitute in 4. See equation 3 in 4. Therefore L1 is equal to what is P1? M1 R1 omega into R1. Therefore L1 is equal to M1 R1 square omega. Consider equation number 5. Therefore the total angular momentum acting on rigid body is given by that is L is equal to L1 plus L2 plus and so on plus Ln. Therefore, consider this is equation 6. Therefore, L is equal to M1 R1 square omega plus M2 R2 square omega plus Mn Rn square omega. Now which is common? Omega is common. Therefore M1 R1 square plus M2 R2 square plus and so on plus Mn Rn square. Therefore L is equal to omega into what is this one? I. I means moment. This also we also write as, we can go for next page. Therefore L is equal to omega common M1 R1 square plus M2 R2 square plus and so on plus Mn Rn square. Therefore L is equal to omega into what is this one? Sigma M R square. Therefore L is equal to omega into I. I is momentum of inertia. Consider this is equation number 7. Since sigma mr square is equal to momentum of inertia Rs, sigma I is equal to 1, sigma I is equal to n, mi Ri square is equal to I. Therefore L is equal to omega into I. Consider equation number 7. Therefore angular momentum is equal to angular velocity into moment of inertia. Therefore, L is equal to omega I. Now, L is equal to omega I, which can be written as omega is equal to L by I, or I is equal to L by omega. So, thank you very much for watching this video. I hope you understood the relation between angular momentum, angular velocity and momentum of inertia.